hoping y'all can hear me. Alright, this is the second stream, so we're still in experimental mode. But we'll see how we go. I have managed to procure a document camera, so I'm going to try and use it today. We'll see how that goes. Thanks for joining me, everybody. My name's Colin. I'm an engineer at AWS. Been here a long time. I helped build some Amazon Web Services. And today I'm going to try and talk about three topics. Everything I'm doing, it's kind of off the cuff, but it's also, part of my job is talking to customers and partners and regulators and all sorts of other folks who we interact with. And I'm kind of going to go over this, common questions they have and some, our common answers and how we think about a few topics. And the biggest topic is what the industry now calls confidential computing. All right, so bear with me a second, and we're going to try to switch to. Okay. Hopefully you can see. I've got these fancy, not too expensive USB document cameras. I got two of them, one for home, one for here. We'll see how it goes, but in real time, I can just scribble away here. I'm going to talk about AWS and confidential computing, Nitro or Nitro System, which is kind of our main answer for that, and Nitro Enclaves, which we launched almost a year ago now, and go over how we think about confidential computing, what those things are, and so on. You see my hand's a bit scraped up. This one's got like some cuts and stuff. Don't worry about that. that is a result of Seattle's crazy sidewalks and the bumps in the trees and falling over and putting out your hand and scraping them up. But it's nothing more than that. All right, so let's get going. So something customers have been asking us more and more about is confidential computing in the last, especially this year. I'd say it's really taken off as a topic in the last year, but the concept's been around a while. And we actually recently put up a blog post around confidential computing and our approach to it and how we think about it and how we offer it on EC2. Mostly what customers are asking for and are asking about is, what's your level of security between, you as the cloud provider and us as somebody who is doing computation, whether that's on EC2 or something like Lambda. Customers treat us as, guardians or custodians of their workloads. And they want to know that we've got high levels of security around that, and ideally, confidentiality. And this is kind of a topic that was central to the design of the Nitro system. When we decided to build Nitro, it was actually probably the biggest thing we were designing for. And I'll go over how that works. But at the time, there was that terminology didn't exist. This concept of confidential computing, which is great terminology. I love the alliteration. Didn't really exist. It also kind of in the industry means a few other things. There are forms of confidential computing that are based on cryptography and encrypting data and doing memory transactions and all sorts of complicated things. And but in all cases, the goal is, customers have workloads, and they want to know that those workloads have strong isolation and confidentiality from the cloud provider, right? Which in our case is us. And I'll get into how we do that and how it works. All right, so I'm going to tear off a sheet, so got some blank pages to work with. So maybe the easiest place to start, right, and how we think about this and how we offer it is, well, Well, firstly, at AWS, we just have a general sense of, it's always our goal um, never to have access to customer data, right? Like we as operators, just as folks running services and so on, if you had, like, let's say in theory, some kind of casual level of access to that material, things would not end well, right? Like it could end up being, logged or sent to places it shouldn't be, and so on. And so, as long as I've been working at AWS, that's been one of the primary focuses of our security team, of our design philosophy, of like just treat customer data as kind of a radioactive thing, and make sure there's like a lead wall around it anytime you're even close to dealing with it, because that's our customers' data, and it could have, personally identifying information in it, PII, or other kinds of sensitive data. And incentives are well aligned here. If there was ever some kind of security issue or operational issue that led to inappropriate data access, it would be a bad day for a customer, but it would certainly be a bad day for us too, right? It would be really, really bad. So there's economic incentives aligned there for sure. But I think even going beyond that, even if you take economic incentives and money out of the equation, I think we all recognize that sometimes, people's personal data, like disclosure of that, can have irreparable consequences. There's just material like somebody's, like, let's say, social security number or something like that. They can't easily change, and you really have to think about it in that context. Like, there's just, you really have to think very hard about protecting all that data. And so that's just always been a part of our design philosophy. Now, when we built Amazon EC2, we built it, our first take on Amazon EC2 was built on very traditional virtualization techniques, right? So customers come along, we had have a web services API they can call, run an instance, and we go and, except for bare metal instances these days, we go and create a virtual machine somewhere on our physical hardware, and we run the customer's software on that virtual machine, right? We boot an AMI for them, or an AMI if you prefer the 3-syllable version, and that virtual machine and a lot of virtualization would run on the same hardware, right? You just have that physical server running everything. And we still have some older generation EC2 instance types that work like that, and that's how we launched. But about, I think, 7 or 8 years ago now, when we began on the path of Nitro, we decided we needed a very different design, both for this kind of confidentiality that I'm talking about today, this kind of enhanced, more rigorous version of confidentiality that goes beyond mere, operational controls, and better performance. And the design of the Nitro system, it's based on, I'll draw it out, right? So you've got a physical, like, EC2 server. Let's just label that. And separately, we've got a Nitro card, right? And I'm going to draw that as a separate box. So let's see, Nitro card. And these are physically separate systems, right? There's an EC2 server, which is a physical machine, with x86 or Graviton 2, processors in it, or these days you can even have a Mac as the physical server, right? And that's what's running the virtual machines, right? So over here in this box, we've got many virtual machines which correspond to EC2 instances, right? That you launch and run your code on, and so on. So these are instances. But physically separate from that hardware, on a separate machine effectively, with its own CPU and its own memory is the Nitro card, or Nitro cards in some cases. And that is where the majority of our virtualization now runs, right, on the Nitro system. So you've got things in here like our storage virtualization, EBS, our networking virtualization, so emulating VPC and ENIs and security groups and ACLs and firewall rules and so on. That mostly happens in here in the Nitro card. And some other things, if you're talking to the DNS server that's serving your EC2 instance, or NTP server, or things like that, those are running over here in the Nitro card. And so straight away from that, right, we've got a really high degree of isolation between the vast majority of our code. I'll go into details in a second about some code that we do run on this physical server, but the vast majority of our code, and the more kind of intricate code, the more higher level services and so on, like the vast majority of say the surface area of our side of the equation of running EC2 kind of runs on this Nitro card, right? A physically separate system, which is different CPU, different memory, different everything than the EC2 server, and straight away that gives us some pretty big confidentiality benefits, right? The code that we as developers of EC2 are writing and running is running on this card, and so there's nothing we can do in that code, and there's no easy path that would let us like inadvertently somehow access data that's over here. We get a strong form of separation kind of built in by default, right, from day one. If we take security and confidentiality out of this, it also gives us great performance, right? We're able to build dedicated hardware engines and co-processors and so on that are part of Nitro that can do things like really fast encryption and not hog any resources from the physical server that the customers are running on, which is a nice property too. And then in bare metal there are no instances here. The customer basically gets the whole physical box, and it's kind of the end of the story. But in when you're using regular EC2, you're using virtualized instances with virtual machines. These are VMs, and then we run the Nitro hypervisor, which does run on the physical hardware. But this hypervisor, the Nitro hypervisor, was designed with a few properties in mind. It's an incredibly minimal hypervisor. It's like just incredibly small surface area and very tiny in terms of functionality, and it's also designed with kind of isolation in mind from day one. In fact, the hypervisor even isolates itself from virtual machines, right? So when it launches virtual machines, it's careful to work with the MMU and the memory managers and so on, so that the address spaces are all kept very separate, and the virtual machine itself is actually memory isolated from the VMs that it's running, because it's essentially all this virtual machine is doing is like the bare minimum it takes to coordinate with the hyper virtualization extensions that are in modern CPUs to basically say, carve out this much memory and give it to this VM, carve out this much memory and give it to that VM, carve out this CPU core and give it to that VM, and so on. There's a few other important points worth mentioning. So we're very, very careful about what resources we ever share between VMs and the hypervisor and things like that. We never share CPU cores between VMs is a good example, and we never share memory between VMs is another strong example. So we're providing a really, really high degree of isolation, both between the VMs, right? Obviously that's needed. You can't have customers being able to crosstalk with one another or anything like that, and between all of these VMs and us, right? Whether it's towards the hypervisor or towards the Nitro card. So that's all in there by design. Like that was just a big part of philosophy. And then the next thing we did in the Nitro system is we decided we would build it as kind of a hands-off, like zero login kind of system, right? So the way we constructed it is to kind of do anything on this EC2 server, to launch a VM, to launch a virtual machine or to do something on the Nitro card, it requires calling an API, right? Our design here is kind of microservices based. We've got microservices running on the Nitro system, and like the only way for us to control the system, like say run an instance or attach an EBS volume or attach an ENI, is to make a call in with an authenticated, encrypted API call that says, run this VM, attach this ENI or whatever, right? And that's it. We do not have SSH access. We don't have any login access. There's no general purpose administrative access to these systems, right? Like even the most senior people in EC2, even the people with the most privileges, even the security team, like they do not have that. There is no way for them to get at this system and just go run or do arbitrary things, right? The only way to get code running on this system is for it to go through our internal code system, which involves, you write the code, you do a code review, it goes through our build process, it gets signed, and then it goes into our deployment pipelines that are, kind of deployed in a staggered way across the fleet and so on, right? And there's all sorts of checks at that point, human and automated, that the code is only capable of doing safe things, right? And so we only expose APIs and we only build APIs through this kind of paranoid lens of we need to make sure that API call is safe, right? Like we would never, and could never actually, but we would never build some API call that's like, just give me access to X, Y, and Z, right? Somehow like break the isolation rules and get access at a thing. And that's enforced at that code level, and it's enforced at that system level, right? Because remember, this virtual machine is actually coordinating with the underlying, like baked into hardware hypervirtualization extensions that are enforcing isolation at the hardware level between all of these things. And so that gives us, and we've kind of always had this, right? Nitro has been built like this since day one. All EC2 Nitro instances get these benefits. Customers don't have to do anything. But this is how we've been able to provide customers with with confidentiality between us and them, right? I can look a customer or a regulator square in the face and tell them pretty straight, look, I don't have access to your data. Like, even though I'm running the physical hardware, there's no command I can go run that would, tell me like what's in your memory. There's nothing I can do to like produce a dump of that, which is, I find very reassuring for them and for me. I just don't want anything like that lying around, and none of the folks who design Nitro do too. This is why it's a core design property. And then we back that too with strong technical paranoia, and we make sure everything's implemented super small, super minimal, because we just don't want to have risks in there or surface area issues. It also gives us a lot of agility, right? If there are, so for example, security issues that might impact underlying hardware, like CPUs, we're still in a position to apply microcode updates and patches and so on for all of those. And there's examples of that happening in the past, right, where we've worked with vendors so that even on day one when an issue goes public, our systems are patched, and we're able to keep just barely enough control to be able to do that kind of thing. So it gives you kind of a nice balance. And so that's the Nitro system, and how it provides a form of confidential computing, right? And the most meaningful form I mean by that is we as the cloud provider can't just go see your data. This is very much, I'm talking about EC2 and Nitro and stuff today. There are other aspects of confidential computing that apply to services that process data and so on. There's all sorts of ways to do like end-to-end encryption and client-side encryption and so on. those are all interesting topics if you have to build an application that has these kinds of requirements. But I'm not really going to go into those. I'm just going to stick to these parts of Nitro. So we really like this kind of strong isolation. When I joined Amazon, kind of 13 years ago now, one of our biggest, most interesting challenges was, how do we keep all the payments data secure, right, for Amazon.com, all those credit cards and so on, right? And I'll draw you a picture of that. But the solution at the time was pretty neat. It was, you'd have the Amazon kind of prod network, we call it, right, where all of our production services would run, right, and we'd have front-end web servers, and then application servers and databases and so on, right, and we as developers are relatively free to build and run things that run inside this network. You have to go through security reviews and availability reviews and operational readiness reviews and so on. But, if I wanted to launch something in prod, I could. And then separate from that, there was a payments network, right? Totally separate network. Physically separate network. Had its own switches, its own routers, all of those kinds of things. And anything to do with credit card data was kind of kept in here, right? And there was a tiny straw of connectivity between the two, and all that was exposed was this very small surface area of a tokenization service, right? So when a customer first kind of created their account, it loaded the credit card number in, and then you got a token back, and from then on you only ever refer to it by its token, right? There was a lot of paranoia around that. It was a very small API, right? You only need 3 or 4 API calls to be able to load credit card numbers, to be able to request charges be made, a few other things. Not a huge surface area, and that was literally all that was exposed between these two things, right? And then the payments network, was kind of paranoia plus plus. So no internet connectivity, no general purpose connectivity. I could not log in or access anything here from my desktop, In fact, if you were a person who needed access to the payments network, and there weren't that many who were allowed to, it was super inconvenient. You would actually physically have to go to a special room that had payments network connectivity added to it. You couldn't use your own computer. You had to use a terminal, and you just got to get your stuff done. And more than once, I got paged to, go fix some payments issue, and you kind of roll your eyes and roll up your sleeves, and okay, I got to go find the PTS room and get into it, and all sorts of access procedures and do all that. So this system, this part of the network was considered just highly ring fenced, highly isolated, right? And you keep everything up to date in here, and it's not like you relax your security procedures just because it's an isolated network, but there's a lot of comfort in having that isolation, right? There's a lot of comfort in knowing that the amount of surface area exposed is very, very small, right? And this kind of compartmentalization and isolation is one of our go-to techniques, and is part of why Nitro is built like this, right? It's let's have these strong lines between ourselves and the customer, and let's have this focused effort on having a very small surface area there, so that we get to enjoy the benefits of that isolation, and we can provide customers with meaningful confidentiality, and so on. And so Nitro Enclaves, right, is part of our goal to make this kind of architecture way easier and way more accessible for more people. We do have customers who replicate this using using VPCs. It's not that uncommon for some of our financial services customers to have a dedicated VPC that has no internet connectivity and is highly ring fenced, and that's where they keep payments infrastructure. I understand they have to go through a lot of compliance and auditing to achieve that, but it's it's not uncommon, and you can do that, but it's not a particularly accessible architecture if you're smaller scale or don't have don't have everything it takes to invest to build that up. So with Nitro Enclaves, what we're trying to do is provide an architecture where a customer can have an EC2 instance, right? And they can kind of, inside that EC2 instance, sort of, you'll see in a bit what's really going on, you can run an enclave, a secure enclave that is highly isolated. So there's a large degree of isolation between these. And you'll see how in a bit. And that this can run some application code to do sensitive data processing, right? And the goal here is, the kind of confidentiality I talked about before for Nitro, where like we don't have access to customers' data, right? There's isolation between us and the customer, right? It's to give the customer that for themselves, right? It's so that the customer, who probably does have login and administrative access to this machine, most customers aren't quite as far along on that journey maybe as we are, although some are maybe even further ahead. There are customers who are who are very much in that mode of build systems that nobody can log into and so on. But many will be able to log into these systems, and you want to be able to provide somewhere that can do some processing that even like if I have root privileges on this instance, I still can't see inside this enclave or see what's going on in there, right? And so that's where you do the sensitive data processing. And so the way it works, right, what's actually going on, the way Nitro Enclaves works is, you run an EC2 instance pretty much as normal, right? You get to pick from our suite of instance sizes all but the very smallest, and you'll see why in a bit, why not the very smallest. And you just run that instance as normal, right? And so that'll end up being, one of these virtual machines running on a physical piece of EC2 hardware somewhere, right? And then from that instance, on that instance, you run a command to say like launch an enclave. And you provide that command a few things. You provided an enclave image, and so that's like a very small AMI. It's just an image, a bootable image of what should run inside the enclave. We actually have tools and utilities to construct those images from Docker container definitions. So it's really convenient. And so you provide that image, and you tell the command how many CPU cores you want to give the enclave and how much memory you want to give the enclave, right? And what Nitro does under the hood is it kind of takes your virtual machine and it removes some of that memory and removes those CPU cores and creates a new peer virtual machine. So this is why I say it's not inside your instance, it's kind of a peer to it or alongside it. A new peer virtual machine with that memory and with those CPU cores that previously were part of the instance, right? And that's now the Nitro Enclave processing environment for your instance. And there's a few things going on there and a few things special about it. Well, so firstly, one thing that's going on there, right, is so since all of the security in Nitro Enclaves is implemented in the Nitro system, right? It's what enforces the memory separation and the CPU core separation and so on between your instance and its enclave. But in order to actually remove the instant or the memory and the CPU core, we do have a kernel module that you run on your EC2 instance, whether it's Linux or Windows, just so that it knows, hey, this memory is about to disappear, the CPU core is about to disappear. We need to, turn those offline and so on. That takes a bit of coordination. So that's one thing that's special. And then the next thing that's special is the instance or the VM, the virtual machine that's created for your Nitro Enclave is different from the virtual machine that's created for a regular EC2 instance in a few ways. So the most important are it has no internet connectivity at all. It's got no IP connectivity of any form, right? It's got no durable storage, so it's got no way to, exfiltrate data over some kind of durable storage. All of those services that you're used to seeing on an EC2 instance, like DNS, NTP, and so on, they're not there. It just has nothing. So it's a very, very, very isolated environment. I kind of like to think of an enclave. It's kind of like you've got your own instance, and then, connected to it over like a serial cable. Oh, I gotta move this. Is the Enclave, right? And I say serial cable because it's not IP connectivity here, and this serial cable, what it actually is it's a VM socket, a VSoC, which is just a virtual machine socket that kind of emulates TCP. Like you could do TCP-like connectivity over a VM socket, but it doesn't use IP. It uses the VSoC protocol, and that gives you this nice benefit that since you're probably going to run a lot of software that does speak IP, like web servers and so on, you can have high confidence they're not going to leak across this barrier. They just can't, right? Because they don't speak VSoC. That's an important point. And so what's going on is, right, that Enclave, it's just this little black box running whatever code you told us to run inside it, with this, bidirectional connectivity between your instance and it and nothing else, right? So it's like a dedicated little machine just for there, but very, very, very highly isolated. Because it's a virtual machine, you can pretty much build any kind of application you want to run inside the Enclave, right? It's anything that's bootable you can run inside here. There's no restrictions at all on like your architecture. You can use any programming language or framework you want. All you're ultimately going to have to be able to do is to make requests over this channel, which is pretty straightforward, and we've got examples and libraries for that. And then to make the security story work, and to be able to do practical things, we integrate with our own Nitro Attestation service. And so what's happening is when we launch this Enclave for you, we checksum it as it's booting, right? And then at any time, the Enclave can ask the Nitro Attestation service, hey, I need a cryptographic proof that I am who I claim I am, right? And this cryptographic proof can be provided to other services, including our own key management service, KMS. And it can that can be used to release key material or other secret material to the Enclave and only to the Enclave, right? And that's a really, really strong form of authentication, right? We're not authenticating the Enclave based on something it has, right? Like a secret or a credential. We're authenticating the Enclave based on what it is, right? Based on the actual running code, right? So you can write your secure application, you can checksum it and vet it and go, yep, that does only what I like. It does only safe operations with my sensitive data. It never, leaks that data or does anything inappropriate. So what I'm going to do then is I'm going to write an IAM policy on my KMS key, and I'm just going to say only that code inside that Enclave can access that key. And then I'm going to go encrypt my sensitive data with that key, right? And then you can load the data in any way you want. You can either bake it into the Enclave image, or you can kind of send it in encrypted over the VSoC. But either way, only the Enclave can decrypt it, right? As long as it's encrypted with one of those keys. We have that first-class integration with our own key management service. It can work with other key management services too. There's no restrictions there. We also built our own application on top of Nitro Enclaves, ACM for Nitro Enclaves. So you can go create a free certificate using Amazon Certificate Manager. And what you can do is you can tell us, okay, I want to push that certificate and its private key directly down to an Enclave running on my instance, and I'm going to hook it up with Nginx, say, on my instance. And so the end result there is, while I'm running Nginx on my instance, it can use that key, it can do things with it, but it doesn't have possession of the key. That's locked safely away inside the Enclave. So it's just one example. We've got customers building other things on top of it too, which is pretty cool. So that's my whirlwind tour of confidential computing, Nitro, and Nitro Enclaves, and the differences between them. I'm going to pause for a bit and try to take stock of the questions that have been coming in and answer them for people. And if you've got more questions, put them in now, and I'll try to address them, because I've got about at least 20 minutes left on my calendar if people have things they want me to cover. And also if people have suggestions for anything else they want me to do in future sessions like this, because I'm going to do more and more. All right, going to scroll back. So the first question I got here was, is there something that would be noticed if we didn't maintain the separations. So yes and no. So I think the average customer of an EC2 instance or any virtualization technology and so on probably wouldn't notice too quickly if we weren't providing rigorous separation, but security researchers would, and they'd probably, I'm sure they'd publish analysis and papers about it, and love to, get the credit for it. There are definitely ways to tell, but they're micro-architectural. You got to be operating pretty low level to be able to detect stuff like that. But it is an active topic of security research, and I'm glad that we have the defenses that we have, and the robust isolation that we have, and that we haven't cut some corners that could be tempting to cut. Why not just share this? It'll save some money or whatever. There's all sorts of times where we've decided not to do that. Does Windows still expose this as a VSOC? Yes. You see Ben answered that. So that's pretty straightforward. And Brent has a link. Cool. Can the Enclave itself be Windows? That is a hard question to answer. So we place no restriction at all on what runs inside the Enclave. Anything that's bootable on that architecture could, in theory, run as an Enclave. And I don't see any technical reason why Windows wouldn't be able to run inside an Enclave. At the same time, it might take a bit of additional engineering for Windows to be the Enclave OS. It is a highly restricted environment with no networking access at all, right? So some things just break. Anything that's dialing home inside an OS won't work. Anything that's trying to do automatic updates or licensing, registration, all those kinds of things don't work. And so stuff like that kind of has to be ironed out. So I believe at the moment no one's been able to make Windows run inside the Enclave. But I think it'd be cool, and hopefully we'll see that. All that said, I like Windows. We support Windows. I'm not trying to slander Windows, but it probably wouldn't be the best choice for a very minimal surface area operating system, that you'd want to run inside an Enclave. The OS, in air quotes, that we run inside an Enclave and we use in area reference and examples, it's not like a full copy of Amazon Linux or something with all of those utilities. It's incredibly stripped down. It's just a kernel, just enough to be bootable. You want a very small surface area in there in general because you're doing sensitive data processing. And even though we've got the defense in depth of that very small surface area VSOC, it's still best practice to keep everything super minimal. Also helps it boot faster and do things like that. Some folks I've seen experimenting with unikernels, which are basically compiling an entire micro OS into one binary, and those also run for Enclave images, which would be pretty cool. And then the next comment is spam, and I'll have to figure out how to block spam on Twitch. Boo. Cool. All right, I'm trying to remember anything I might have missed in all that. I guess going back to Nitro a bit, in case it's not clear. So I talked about confidential computing here, and about how we have the Nitro card over here with our code on it, and then we run the virtual machines, and we've got the very small surface area hypervisor. I should say, you don't have to live with this hypervisor. If you'd like to eliminate even any risk you might consider with this, very small, very well engineered, highly secured hypervisor, you can take it off the table by running bare metal, right? In which case, this red box goes away, and you pretty much get this whole blue box, right? And our Mac instances are a good example of that, right? Where it's physically a Mac, right? It's literally a physical Mac Mini, right? And we just have a Nitro card plugged into it externally, right? And there's none of our code, running on that physical hardware. And that can provide you with an even more enhanced version of confidentiality if you want to consider it for something like that. So that's another cool option for folks too, which I should have mentioned. don't think I've got much else to mention though. Tentatively planning. I don't know if I'll do one of these next week because I'm traveling. So it might be 2 weeks before I do another one of these. Tentatively planning do a pretty small or dive into cryptographic side channels and side channel analysis for mortals, like not for won't have to be a cryptographer or a mathematician or deep into security engineering to understand it. Hopefully, really want to try to explain it in friendly terms. But if people have other topics or other things that would be interesting, let me know. And I'm gonna keep building on this. Based on the last video I did, I got a couple of hundred views kind of after the fact, which is great. So I'm gonna keep it up if people are interested to that level. It's a good way for me to practice too. Oh, here we go. What are some directions on confidential computing that I'm excited about? Well, I'm excited about Nitro Enclaves. I know there are other approaches to confidential computing. So you've got the SGXs and the SEVs and so on, which are kind of in CPU technologies, and I like those. And the way EC2 works, right? We generally pick up all the latest hardware and all the latest CPUs that vendors have, and when it's reached the right point, that CPU supports those features and supports all the other features we need, many of which are also for important security. For security reasons, like I predict there'll be future instance types that have those too, right? Which is I'm excited about because there are customers who use those, but I'm excited to have a product like Nitro Enclaves that's a very different shape than those. On those platforms, you tend to have to use those enclave technologies. You tend to have to use memory transactions, which are really complicated. And you tend to have to operate at a really low level. In some cases, like literally be coding, at the assembly level, or use libraries that are kind of do that for you and provide slightly higher level abstractions. But I haven't seen those take off quite as much yet. A lot of things around them seem to be science projects more than built out use cases. So I'm excited to have a version like Nitro Enclaves where just have a machine. Here, just have a machine, just run your code on a machine, and we're going to highly isolate that machine. And it's nice to see customers getting up and running at that. We had some folks build on it super fast, so that's exciting. All right, let me go through the rest. Do I expect confidential computing to become required for regulated industries? So I have conversations with regulators all the time, and confidential computing comes up, and like I did here, dove into how Nitro works, how we provide confidentiality between us and the instance, how we provide that on bare metal, how we provide that for virtualized instances and so on. And there's never a single answer for a regulated or a compliance workload. Often every workload has to go through with its auditors and regulators, and it's a one by one conversation because they like to go so deep. But we've certainly been able to satisfy customers and their regulators in many cases, and have those workloads running on top of Nitro. So that it's pretty cool. And obviously we're showing up on day one where we have our own application ACM for Nitro Enclaves where we're running on top of it, and we kind of have our own internal pseudo regulator in the form of AWS Security, who go really, really deep and make sure that's works before we're allowed to do something like that. So that's pretty cool. Given the EC2 server runs multiple EC2 instances and the Nitro card runs microservices for shared services that instances depend on, how is isolation between customer instances achieved there? Does the Nitro card not know about the various instances it's serving? We use a bunch of engineering techniques. So the most important, right, is on this side of things are relatively simple, right? We use the hyper-virtualization extensions that are built into CPUs. And the CPUs enforce, right, at the hardware level, like this instance can't see this other instance's memory, can't use this other instance's cores, and so on, right? Like that's pretty That's pretty straightforward. We've lots of ways to test for that. We do our own research on, things like side channels and emerging techniques and so on. And that's always something I think we're doing a really good job on staying ahead of, which is kind of cool. On the Nitro card, there's different engineering techniques apply for different things. Often it's as simple as, kind of replicating this stack over here, giving each customer, each instance its own dedicated, piece of software or process and so on to do the work. But a lot of the Nitro processing happens in hardware, right? It's an accelerated system. And so that hardware is also able to add kind of additional constraints. So you don't have to just rely on software. But it's mostly, building multi-tenant systems is kind of our core competency. That's what it's what a cloud provider is, right? And so we've got all sorts of techniques there. From my perspective, isolation is one of the easier to achieve properties. The harder ones are, making sure that there's no cross customer noisy neighbor issues or something that could be degrading performance and so on. And more advanced engineering goes into that. Things like shuffle sharding and so on are techniques there. I missed it. Did I talk about memory encryption of the Enclave? I didn't talk about the memory encryption of the Enclave. So we do memory encryption on some platforms, including Graviton 2, right? And we just do it. All the memory is just encrypted, right? We don't consider memory encryption our main isolation technique, and we don't think it's a good one, to be honest, to be blunt about it. Memory encryption, the challenge with memory encryption is when you rely on memory encryption as your isolation technique, if something can see the encrypted memory, it can still see things like the rate of change. It can see things like the total amount of memory being used. There's all sorts of ways it can infer things from that. In the CPU space, that kind of visibility, like caching and so on, has generally been a negative. That's why we don't share CPU cores. And just relying on encryption there makes us very nervous. So what we do use encryption, but we don't rely on it, and we instead rely on hard separation and just literally you can't even address that memory, you can't even see it, being a much stronger form of isolation. And that's why we have virtual machines as our boundary between things. In general, anytime we're trying to execute code in different security contexts, we go to virtual machines. Lambda functions are run inside virtual machines. EC2 instances are run inside virtual machines. Enclaves are run inside of virtual machines. And that's because virtual machines give you this nice, big, clean abstraction to be able to make sure, this virtual machine cannot see this other virtual machine's resources. And I work on cryptography, and I just don't think cryptography has that level of isolation. And so it's not our go-to technique there. But we do use it where we have it, for additional defense in depth and for defending against some other threats that encryption can be useful for. A deep dish dive on how EC2 and other services use KMS. Yes, okay, that's a good future one. There's definitely and the way EC2 uses KMS is interesting, so that's kind of cool. Specifically, is it encrypted to protect against some kind of memory side channel? That's an interesting question. Kind of going back to what I was just saying. No, and in fact, if you just use encryption as your isolation technique, I would say you have made it more vulnerable to a memory side channel, not less, right? Because there can be all sorts of properties of how that encryption and decryption occurs that people can be very clever about trying to exploit. And there's a lot of emerging security research, many papers that have found side channels like that in isolation systems that are purely based on encryption. So I actually take the opposite view, and it's kind of to me, it's look, if you make me choose between two machines that are just separate, or make me choose between one machine and then I'm going to have some space on this machine that's going to be encrypted, but the machine's still going to be able to see the encrypted data, I'm just like, give me the two machines. You know, they're just obviously more separate, and it kind of is as simple as that sometimes, and that's our philosophy on it. And you know, some of it may be down to you know, when you go that deep on cryptography and you work on it a lot, you start to realize, you know, where its pitfalls can be. Great. I think I got through all the questions that were there, which is good. Thanks everybody for joining me. I'm glad this document camera works. I'll watch the video later to see if I had any frame drops or whatnot. I don't know how that is. I probably should have gone back to this view more often than I did, which is not at all, but maybe I'll get better at that. Thanks for joining me. Until the next one of these, have a great weekend. If you're in Seattle, watch out for the rain. Bye.